So let's maybe just do number 4 from yesterday's work, just as a refresher about how to use the empirical rule. So Alan, given a calculus exam. That's exciting. His scores were low. That's not as exciting. But the mean of 62 and a standard deviation of 4. And it says, all right, if a student is selected at random, what's the probability the score is less than 66? So we want to know the chance that x is less than 66, where x is the score on calc exam. So high school exam, there we go, exam. I'm going to draw a normal curve. I'm going to center it at the 62 as it's set above. And the standard deviation is going up by 4s, so we know this would be at 66, 70, 74. And this would be at 58, Pfeiffer, and 50. And then it says being less than 66, so that'd be here. And then what I'm doing in my head, at least, is I'm thinking about those regions. So you could always mark them down if you want to. If you want to, you can also just use the power of memory. So this was 34%, 34%, 13.5, 2.35, and 0.15%. So the chance of being less than 66, I'm just going to add up all of these areas to the left. And that's going to be, I believe, 97.5%. Yeah, I'm just going to go with that. That seems pretty good. And then technically this is approximately. I got to make sure I put approximately there. The empirical rule is all approximate. B says if a student selected at random, what's the probability that they get between 58 and 70? So probability between 58 and 70. 13.5% right there. And so 58 to 70, I'm just going to add 68. That's 34, 34, and 13.5, which should be 81.5%. Hopefully nothing too scary there. It really is just all about this graphic. These numbers are fixed, these percentages. So these are the only things that change based on the problem's mean and standard deviation. And then finally says, what score is at the top 2.5%? So I'm definitely looking on the right side. And this is 2.35%. This is 0.15%. And so hopefully you recognize if you add these two regions, that adds up to be 2.5%. So 70 is in the top 2.5%. So a score of 70 was in the top 2.5%, which is not very good. There was no kidding when it said the test scores were low. The top 2.5% was a 70 on the test. All right, come with me and let's take a journey back to the land of PowerPoint. Let's start some more fun stuff. Where are you? Where are you? This is always good video watching. Yeah, there we go. Okay, so this is the interesting part, which is, will my calculator do any of this stuff that I was just doing on paper where I had to like draw this out, add these up? And the answer is, yeah, it totally does that. And I'm going to be using my TI calculator, but if you don't happen to have a TI calculator, I found this website just by Googling right now. Let's see. I think I Googled normal distribution calculator, and it's on Statistics Helper. And this is going to do exactly what I'm doing when it comes to finding area. This is not going to be doing inverse norm. I got to find a calculator for that in a second. It'd be ideal that you have a calculator, though. It makes it much easier to do this stuff if you have a calculator. All right. So what we're going to be using today in our calculators are the normal CDF function, which finds probability, and the inverse norm function, which takes probability and finds an x value. So these are the two things we'll be doing. Normal CDF finds probability. Inverse norm takes in probability and spits out the value that gives you that probability. All right. So this is a problem from yesterday, which was the heights for male students was normally distributed, centered at 71, standard deviation is 2.5. So these are the values we already knew. And what we're going to do is find this answer here. What percent of the male students are shorter than 66 inches, which we already know is about 2.5% based on the empirical rule. Let's add those two together. We're going to use our calculator instead. And the way we're going to do this is choosing normal CDF. And then we have to input our lower bound, upper bound, the mean, and standard deviation. And so for this problem, the lower bound is going to be negative infinity. The upper bound is going to be 66, because we're curious about people less than 66. The PowerPoint should be on Google Classroom, yes. And then the mean is 71 as defined by this curve, and then this standard deviation is 2.5. So let me show you how to get this in El Calculadora. These button presses are pretty important. You're going to probably want to write down how to get to them. So step one is we're going to hit second and then vars, which goes to distributions. So second, distributions. Should bring up this screen. We've seen this before. We had to do a lot of stuff with binomial PDF and CDF recently. Now what we're going to choose is normal CDF. It also finds probability just like binomial PDF and CDF did. So we're going to choose normal CDF. Now in this case, our lower bound is technically negative infinity. And I'll show you the picture again, just so you can see what I'm talking about. We want to go from 66 or shorter. So technically that just keeps going and going and going. You might be thinking, well, what, isn't 0 kind of the lower bound? Yeah, you're probably right. And it doesn't matter if we go much further than that. But really the curve does keep going, even if it's not physically possible for a human to be negative. We're still going to go from negative infinity till 66. Now the number that we're going to end up plugging in is not infinity, because that's not like a number. So instead, we're going to choose a really big negative. There's a couple of options here. You can use -1 E99. And I think the way you get that E, let me see. So you would just type -1, it's like -1 like you're used to. And then the E you have to use is this guy right here. You hit second and then comma. That gives you the E and then 99. This is telling your calculator to do a -1 followed by 99 zeros. This is just a very big negative number. You could also just like do -2 to the 99th power. That's a really big negative number. That works. You could also just say negative and then just mash the number 9 a couple of times. These are all fine. We just want a lower bound that's very, very far negative. Our upper bound was 66 that we cared about. We want people shorter than 66. The height was centered at 72, I think, or maybe it was 70. Let me go back to the PowerPoint. So memory, 71. 71. And then the standard deviation was 2.5. So negative infinity-ish to 66, centered at 71 with a standard deviation of 2.5. Hit the old paste button. And it's telling you the chance of being there is 0.0227, which is not exactly what our empirical rule had. Our empirical rule said it was, I think, 2.5. Less than 66, and that's okay. I mean, the empirical rule is an estimation, so you're not going to get exactly the same answer. This was 2.5%, and we got a more exact answer, which is 0.023. And if you use that online calculator that I just showed you, hopefully, it should work here the same. So it says enter a number or -E99 for negative infinity, so -1 E99, and then enter the upper bound, which was 66, mean 71, standard deviation 2.5, and then hopefully we can hit the calculate button and get our answer. And there it is, like went up right there. This just shows you that if you don't have a TI calculator at home, there are options. The internet has stuff for you. And so this is just an important idea. The empirical rule is an approximation, which is why the calculator answer is slightly different than that 0.025 from the empirical rule. We would expect 2.5%, but we got 2.3%. That's just the nature of the empirical rule, which is just an estimation. I'll do a couple more of these. So this one wants people taller than 73.5. So taller than 73.5. I'm going to go back to second distributions, second vars, normal CDF. We want it taller than, I wish my memory wasn't so terrible, taller than 73.5. So I'm going to type in 73.5. We now have to go to positive infinity. And so you can do that by typing a 1 and then second comma, which is where that e variable is, stands for times 10, and then to the 99th. So it's 1 followed by 99 zeros. This is positive infinity. Still centered at 71, standard deviation is 2.5. Hit the old paste button. And then we get our probability, which is 0.158, which is about 16%. Make sure you round appropriately based on whatever MyMathLab is asking you to do. And once you get this down, I mean, there's not a whole lot to it. You put in your lower bound, upper bound for what you're doing, centered at whatever the mean is, standard deviation is whatever, and you get your answer. So male students between 66 and 73.5, I would put in my lower bound at 66, upper bound is 73.5, centered at 71, 2.5. There you go. It's about 81.9%. Here's where it starts getting different. This is going to involve inverse norm. So they gave us the percentage. They already told us the probability, and they're asking us to find the students that are shorter than that height. So approximately 84% of the students are shorter than what height? So we're looking for a tall person because 84% of the people are shorter than that height. So we're probably going to get something on this side. The way we're going to do that is by using something called inverse norm. It undoes a normal CDF. It takes in probability, which we're going to call area. Those are synonymous in statistics. So we're going to put in the probability to the left and then still specify where the curve is centered and what its standard deviation is. So in your calculator, what you're going to do, when they give you a probability, is you're going to hit second vars again, and you're going to choose inverse norm. So the two main things you're going to be using this unit for normal stuff is normal CDF or inverse norm. Don't worry about normal PDF. We do not ever use normal PDF. So don't think about normal PDF. Just stop it. No normal PDF. So anyway, we're going to choose inverse norm, and the area was 84% to the left. Inverse norm only works with area to the left. You have to put in the area to the left. That's worth making a note about. I'll point it out a couple more times, but that's really important. This is the area to the left. Some newer calculators do have the option to do left, center, right. I don't have those newer calculators, but those do exist. But for the purpose of me teaching you, I'm going to tell you this area is always to the left. The center was still 71 inches, and the standard deviation is 2.5. And so what this is going to do is it's going to find the height that is taller than 84% of the people for this population. And so that's apparently 73.49. 73.49 inches is taller than 84% of the population. And there you go. Make sure you put inches on this because now you're finding an actual value of height. So you need to make sure you put the correct units. Approximately 97.5% of the students are taller than what height? So this is where it gets a little bit tricky. So this is talking about a shorter person because approximately 97.5% of people are taller than that height. So there's going to be a person on this end. And remember, the calculator only works for less than percentages. You can only go to the left with your area. And what I mean by that, let me just show you. I'll go to this real quick. So for the last problem, we wanted to find a height that was taller than 84%. So we knew that this area to the left was 84%. And I can feed this directly into inverse norm. So I just said, all right, to find this value, we did x is equal to inverse norm of 0.84 centered at 71, 2.5. Easy peasy, super easy. This current question, though, says we want to find a person such that 97.5% are taller than them. So it's asking us to find this, which is 97.5%. And then what I just said is that normal CDF, or sorry, inverse norm, only finds area to the left. So you have to actually think about this piece here. Even though the question said 97.5, that was the area to the right. We have to figure out the area to the left, which is really simple. It's 1 minus that 0.975. And so that'd be 2.5%. Remember, you can write percentages as either decimal or you could say 2.5%. Either one's fine. So that is what I have to type into my calculator. Remember, inverse norm, area, this thing right here is only to the left. That's the only way the calculator thinks about things. So if we want to find this x value, instead of saying 97.5, I have to say 2.5. It's still talking about the same spot, but your calculator only understands to the left. It's a Beyonce song, or it's in a Beyonce song at least. So we still put in our area, our mean, and our standard deviation. But it's the area to the left of the value that I'm interested in. And that is why, even though it's saying approximately 97.5% of students are taller than a value, instead we have to type in that 2.5% instead of the 97.5%. This is probably the trickiest part about today's lesson. I don't think it's that bad, but that's maybe the hump you're gonna have to get over. And we find out that 66.1 inches is the height such that 97.5% of people are taller than them. And then, so here are the strategies we're going to have first for finding probabilities. These are the first couple of problems we did. I would always suggest drawing a picture for every single problem. Very quick sketch. Write the probability statement that you're looking for. Calculate the probability using the normal CDF. And when I say draw the picture, I'm just recognizing I didn't say shade. I would shade also. And then it says write a complete sentence for the probability. This is not as super important. The probability statement itself works just as well. I'll show you what I mean by that. And then when it comes to finding the boundary, which is what we did at the end, this is us finding the boundaries, saying like, what is this value here at this boundary where 97.5% are taller? I still suggest drawing a picture. This is going to help you out immensely. Shade the area to the left or the right that you care about. And then you're going to calculate that boundary using inverse norm. Super easy. All right. And I think probably good here. No, actually, maybe we have like a couple more slides. Okay, so this one says the lifetime of a certain type of battery is normally distributed. Make sure you're paying attention to that because it could also be uniform. That's what we learned first in this unit. With a mean of 200 hours and a standard deviation of 15 hours. And it wants to know, what is the probability that a battery lasts less than 220 hours? So first thing we're going to do is draw a picture centered at 200 because it told us it's centered at 200. It told us it's normal, and it told us the standard deviation was 15. We want to find what's the chance of being lasting less than 220 hours. So we want to find this probability. In order to do that, we're going to use normal CDF. So the chance that x is less than 220 is just going to be the normal CDF from negative infinity to 220, centered at the average of 200 with a standard deviation of 15. That gives you your answer. It's the end of the problem. And this is just them kind of conceptualizing it. The probability that a battery will last less than 220 hours is 0.909. That's just basically rewriting what this says. This was in symbolic form. This is like in English form. All right. What's the probability that it will last more than 220 hours? So now we're going to draw another picture, shade to the right of 220. And so normal CDF 220 to infinity, centered at 200 with a standard deviation of 15. And that gives you 0.091, which is just the complement of what we just found. Lasting less than 190 hours, shade, probability statement, put into normal CDF, negative infinity to 190, centered at the average of 200 with a standard deviation of 15. These are pretty repetitive once you understand what's going on, especially if you have a calculator in front of you. You can probably figure this out in a few minutes. The probability that a battery will last less than 190 hours is apparently 0.252. This one's asking between two values, which is super easy because you're just using normal CDF. So if you want to know the chance of being between 170 and 210, you just put that as your lower bound and your upper bound, 170 to 210. Centered at the average of 200, standard deviation of 15. So there's a 72.5% chance that a battery lasts between 210 hours and 170 hours. This is where we have to now use inverse norm, and you can tell because it gave you a percentage, a percentage, that they gave you a probability, and they're asking you, what's the life of a battery at the 75th percentile? So we want to find what is the X value here. We don't know at this time, but we do know this area is 75%. So this is different than the previous problems. The previous problems were saying, here are the X values, find the area. This problem is saying, here's the area, find that X value. So what we're going to do is use inverse norm. We want to find some X value such that we get 75% to the left. So we're going to use the inverse norm of 0.75, that's the area, and still centered at 200, that's the average, with a standard deviation of 15. So inverse norm is always the area to the left. In this case, it's 210.117 hours. That's the X value here. They told us the percentage. We just plugged it into inverse norm. They gave us the mean standard deviation, and it just spit out the X value. This last one, I think, is the last one. Yeah. How long must the battery last to be in the top 5%? So this is the only one I see you guys possibly messing up if you're not being careful. Make sure you shade and you recognize, this is the area to the right, the top 5%. My calculator does not understand top 5%. So instead, I have to talk about the bottom 95%. This white space, this area to the right, or sorry, to the left, and that's all white. That's going to give me my answer here at X. You have to always tell the calculator the area to the left of your X value. So 0.95, 215, that gives you the 224.673. All right, that should be about it for the notes.